Hello students, in the last class we came to know about the meaning of squares and we are trying to make some patterns how to get the square numbers, no? So among which one of the item we studied is there are two non-perfect square numbers between the squares of the number n and n plus 1. We saw in the note now in the last class. Let us verify this one by taking some examples here. How many natural numbers lie between 9 square and 10 square now? Let us calculate by using that rule. So that is 10 square minus 9 square means 100 minus 81. So 19 natural numbers will be there between 9 square and 10 square. That is any two consecutive squares. How many natural numbers will be present? So square difference of those two squares will give the number of natural numbers. Now take one more example. How many non-square numbers lie between 100 square and 101 square? So without calculating it, we can identify or calculate here. You see here 101 square minus 100 square. That is 10,000. That is 10,201 minus 10,000 gives 201 natural numbers. So smaller ones means like we can see by writing itself, but bigger numbers we have to go for like this only. That means by the rule there are 2n non-perfect square numbers between the squares of the square numbers n and n plus 1 here. Now you see here. Go for some homework here. Find the non-perfect square number between 11 square and 12 square by using this rule itself. Okay. Find the non-perfect square number lie between 99 square and 100 square. Now we shall go for one more way of getting the square number or pattern of numbers here. Square numbers. We can also get perfect square number by adding successive odd numbers starting from 1. That means by adding the successive odd numbers from 1. So 1 plus 3, 4. 4 is the square of 2. Again 1 plus 3 plus 5. It is 9, no? 9 is the square of 3. Again 1 plus 3 plus 5 plus 9. 7. That will leads to the square numbers here. That is 1 is equal to 1. That is equal to 1 square. 1 plus 3 odd numbers. Adding the odd numbers, successive odd numbers. You see 1 plus 3 is 4. 4 is the square of 2. Similarly 1 plus 3 plus 5 is 9. 9 is the square of 3. So again 1, 3, 5, 7. Adding that we leads to 16. 16 is the square of 4. In this way we are going to get. That means in general by seeing that we are seeing 1, 4, 9, 16. So we can represent that first n, sum of first n odd numbers are of the form n square, no? 1, 2, 3, that is 1 square, 2 square, 3 square, 4 square, etc. etc. That will leads to n square. In general, the sum of first n odd natural numbers is n square. You have to remember these rules because in the next year, that is in the coming years, in the college also, you are going to see the pattern of these type. You are going to make the sum and that is sum of the terms series you are going to study. That's why arithmetic series, geometric series, like that. That's why you have to remember these items, notable points here. In the coming days you are going to learn more about this one. So one more thing that is we can see here is if a natural number cannot be expressed as a sum of successive odd numbers starting with 1, then it is not a perfect square. That means by seeing this we can define non-perfect square numbers. That means what is a non-perfect square number? In other words, we can see We can define as if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. Okay. So for this, let us take some examples and verify whether it is true or not. Find whether 121 is a perfect square or not. We have to find 121 is a perfect square or not. We have to verify by applying that rule. Let us see. Let us see this one. Starting with 1 here. Okay, starting from 1. Subtract 1 from 121. So you will get 120. Again subtract 3 successive odd numbers. Subtract 3 from 120. You will get 117. Subtract 5 from 117. You will get 112. 112 minus 7 gives 105. 105 minus 9, 96. 96 minus 11, 85. 85 minus 13, 72. 72 minus 15, 57. 57 minus 17, 40. 40 minus 19, 21. 21 minus 21 is 0. We are getting 0 at the end by subtracting the successive odd numbers from 1. Start from 1. So we are getting 0 here at last. Therefore, here we get 0 at the end when we subtract successive odd numbers starting from 1 by the given number. Hence, 121 is a perfect square number. Whose perfect square it is? That how many times we subtracted odd numbers? That means 11 times, no? So therefore, 121 is the 11 square. You can see that is 121 is equal to 11 square. Since we get 11th time as 0 by successive subtraction of odd numbers starting from 1 here. Let us verify one more number here, whether it is square or not. 69, let me take 69. We have to verify whether 69 is a perfect square or not. Now you see what you are going to get. Start from 1 is again. So that is 69 minus 1, 68. 68 minus 3, 65. 65 minus 5, 60. 60 minus 7, 53. 53 minus 9 is 44. 44 minus 11 is 33. 33 minus 13, 20. 20 minus 15 is 5. Again 5 minus 17 is equal to minus 12. That means we are getting a negative number, not 0. Okay. So we are getting negative number here. Here we get negative number at the end when we subtract successively odd numbers starting from 1 by the given number. Hence 69 is not a perfect square number. If we get 0 by subtracting successive odd numbers starting from 1 by the given number, if we get 0, then it is a perfect square number, because some of the odd numbers, successive odd numbers starting with 1, if we represent like that, that will becomes a perfect square. Otherwise it is not. No, by seeing these things we can confirm. So you do some exercise to understand more about this. So take some homework as that is by the applying that same rule. Find whether 55, 81 and 49 are perfect square or not. You have to give the reason, proper reason for this. If they are perfect square, why they are perfect squares. If they are not, why they are not. Okay. Note here, one more item we have to study. Now another pattern that we get a square number is, a perfect square number can be also represented as sum of two consecutive natural numbers. We can represent any perfect square number as the sum of two consecutive natural numbers. But its converse is not true. Okay, I will tell you what it is exactly. So that is example, 3 square is equal to 9, no? 3 square is 9. 9 can be represented as 4 plus 5 here. You see 4 and 5 are consecutive natural numbers. 4 is in the form of n square minus 1 by 2. That is 3 square minus 1 is 8. That is 3 square is 9. 9 minus 1 is 8. 8 by 2 is 4. Is it not? Now 5, how you are going to get? N square plus 1 by 2. That is 3 square is 9. 9 plus 1 is 10. 10 by 2 is 5. Similarly, we can get, you see here 11 square. Just now only we confirmed that 11 square is 121. So 121 can also be written as 60 plus 61. Is it not? So that 60 can also again we can represent that as, that is again it will come in the next slide. You see 60 plus 61. 60 square is 360. 360 no? So that is 60 square is 3060. 6 6 are 36 again 2 zeros. 3060. 3600 minus 1 3599. Okay, so in that way we can represent this 60 plus 61. Sum of two natural numbers we can represent. 60 plus 61 is again 121. So 15 square. 15 square can also be represented as 112 plus 113. That is 225 now. 15 square is 225. The 225 can be written as 112 plus 113. So, okay, in this way we can represent any perfect square number as a sum of two consecutive natural numbers. For this, let us verify this rule by taking some examples or problems here. So, you see, let us express 21 as a sum of two consecutive integers. Okay, so let me take n as 21. That is a given number. So that is as my rule, as the rule says. So it's previous now, that is first number is n square minus 1 by 2 form. No, that is 21 square minus 1 by 2. That is 441 minus 1 by 2 is 440 by 2 is 220. Okay, so that is the first number is 220. The other number one will be 221 now. Next, sum of two consecutive integers 220 and 221, that is n square plus 1 by 2 form. You have to remember this one. So to identify the consecutive natural numbers or integers between that to represent a square number. So this is how the Ramanujan work with these type of numbers. N square plus 1 by 2 form, that is 21 square plus 1, 441 plus 1 is 442 by 2 is 221. If you add 220 plus 221, we will get, it is 441 is the square of 21. Therefore 21 square is a 441. That 441 can be represented as sum of two consecutive natural number is 220 plus 221. Okay, this is what the rule behind this. To express any square number as the sum of two consecutive natural numbers or integers, we have to go for this is n square minus 1 by 2 and n square plus 1 by 2 form. Then only we can calculate that one. For this, take some examples or say some homework for you. Express 13 square, 11 square and 19 square as the sum of two consecutive integers by applying that previous rule. Okay, and now let us go for the one more pattern of square numbers, so that any square number can be expressed as the product of two consecutive even or odd natural numbers. You can see, you see, that means you see here, that is 11 into 13 gives 141. That is 143 we get. Okay, 11 into 33. 11 into 33 is can be represented as, you see, 12 minus 1 into 12 plus 1. That is 12 minus 1 into 12 plus 1 is exactly is of the form a plus b into a minus b. No, that is a square minus b square. That is b is 1, 1 square is 1 always. Therefore, a square is here 12 square, 12 square minus 1. That is, we can represent that if we subtract 1 from any perfect square number, can be expressed as the a square a minus 1 into a plus 1 form. That is equal to a square minus 1 we get. Okay, so that means any you take any two consecutive even or odd natural numbers, you will get this form here. That is, you take 13 into 15, next two consecutive numbers only, odd numbers, or even natural numbers, you will get the square, that is a square minus 1 form only. So that is 13 and 15. 13 into 15 can be represented as 1 greater than 13 is 14. 1 less than 14 is, that is 1 greater than 14 is 15. 1 less than 13 is 14 minus 1. No? 14 minus 1 and 14 plus 1. The product of those two gives 14 square minus 1. You can go for one more here, 29 and 31. Take the product of those two consecutive odd numbers, 29 and 31. 29 is 1 less than 30, 31 is 1 more than 30. No, so that is 30 minus 1 into 30 plus 1 we can represent. It is same as 30 square minus 1. So this is what the rule behind this. That means perfect square number, when 1 is subtracted from any perfect square number, we can represent that as the product of two consecutive even or odd natural numbers here. You go for even consecutive even numbers here, 44 into 46. So 1 less than 44 is 1 less than 45 is 45 minus 1 is, that is 44. 1 more than 45 is 46 here. 46 so means 45 plus 1 we can represent. That means 45 minus 1 into 45 plus 1 can be represented as 45 minus 45 square minus 1. So by taking the general form of this, we can say that if 1 is subtracted from any square number a, then it can be represented as a plus 1 into a minus 1 is equal to a square minus 1. So that is product of two consecutive even or odd natural numbers. By this we can also find a perfect square number. Is it? So this is all the ways we can get, how we can get the perfect squares by different methods here. So you see, look at these pattern of numbers. You see how crazy these are. But these are all always true here. These are called as palindromes. Okay, palindrome. Palindrome means if you read a number from left to right or right to left, you will get the same value. Value cannot be changes here. So this is Pingala's pyramid of palindrome here. That is 1 square is 1, 11 square is 121. You see, you read from left to right or right to left, you will get the same value. So 111 square is 12321. That is 1111 square. That is 11. That is 1111 square is here 12,34,321 means that is 1 2 3 4 3 2 1. If you read from right to left or right to left to right, you will get the same value. Is it? So by go on like this, how can we represent the last number? It is 111 etc etc etc. 111 square is equal to 1 2 3 etc 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 3 2 1. That is will be the last Pingala's basic, that is last palindrome. Okay, so you see that can also be written. Some more patterns are like this. You see, you can look at this pattern, how you get the 7 7 plays an important role. 7, 6, 8. You see decreasing numbers. 7 square is 49. 4 and 9 now. 67 square. 1 less than 7 is 6 no, 67 square. So double 4, 8, 9. Unit place same. 1 less than 9 is 8. Again double the 4 here. So that pattern will continue. 67 square. Similarly 6667 square, that is 667 square. So that is 444, 889. Look at this. Is it an interesting pattern? No. So that is 6667 square. This 4 times 4 repeats here. 4 4 4 4. 3 times 8 repeats. 3 8 8 8. 9 remains same here. Similarly, you go for this 66667 square. It is 5 times 4. 4 times 8, 19. Is it? So interesting patterns. The square numbers have very interesting patterns here. Some more patterns are like this. You see, 11 square. We discussed 121. 101 square. 10201. You see, this is also palindrome. Okay, so that is 10101 square. Now you see what is happening. 102030201. Is it? It is 1010101 square. That is 1020304030201. So if we continue like this, we will get the some more pattern. That is similarly we are getting the same pattern like these numbers here. These are all again perfect square numbers, bigger perfect square numbers. So you can see this one. Similarly, you look at this pattern. So this is also same, I think. So not worried. So look at this pattern. How it goes. It is 1 square plus 2 square plus 2 square is equal to 3 square. So what is the rule behind this? That is first number is 1. Next number is 2. So the product of those two will be 2. The third number. 1 2s are 2. That is first number is 1. Second number is 2. So therefore 2 1s are 2. Third number is 2 again. It is exactly the sum of those 3 squares is a 3 square. Sum of those 3 squares is a 3 square here. 1 square plus 2 square is a 5. 5 plus 4 is 9. 9 square. 9 means it is a square of 3. Similarly, you go for this. 2 square, 3 square plus 6 square. 2 square plus 3 square plus 6 square. Again, first number is 2. The second number is 3. Product of those two is 2 3 is 6 is the third number, which is exactly the square of 1 more than the third number. That is 7 square. Is it? So third number, that is exactly 1 more than the third number square. Okay. Similarly, we can go for this. 3 4. Look at here. 3 4s are 12. Third number we are getting. So 1 more than 12 is 13, which is exactly sum of those 3 squares is the 13 square. We can get like this. That is, you can go for one more. Look at this. 4 square plus 5 square is plus 20 square is equal to 21 square. That means 4 and 5. Product of 4 into 5 is 20. So 1 more than 20 is 21. So the first number is 4, second number is 5. Two consecutive numbers. Is it? Sum of those two squares is the product of the first and second square. Second numbers is the third numbers. Okay. 4 square plus 5 square plus 20 square is equal to 21 square. Similarly, you see one more number. 5 square plus 6 square plus 30 square is equal to 31 square. It is 5 6 are 30. 1 more than 30 is 31. So like that it will continues. So these are all the different patterns here. Don't write this. This is double time printed. So okay, these are all some of the interesting patterns how we can get the larger square numbers, to get the larger square numbers and identify how to write the square numbers. So these are all very important to know or to identify a perfect square numbers. And now you can come to judge which are the perfect square numbers and which are not the perfect squares. Okay, in this way we can identify and judge. There are so many exercises in your textbook. You can see easily solve those examples or problems by knowing these concepts. In the next class, we shall study how to find the square root. What is the meaning of square root and how to find a square root of a perfect square number, square root of decimals. So there are different methods. Let us understand in the next class. Uh, Children, remember all these everything and write these in your notes. Thank you.